You'd never know it, but there's a side of quarrying nobody ever sees. When the sun sets and the crews leave, when the gates lie locked and the site sits silent and still, quarries offer up their secrets to those who know where to look. Welcome to the secret life of quarries. There are countless ways to make a quarrying operation more sustainable, but most involve reducing CO2 emissions. And the number one way to release less CO2 with today's machinery is to use less fuel. Across the world, humanity is exploring ways to reduce its carbon emissions, to mitigate the impact of climate change, and that's true of quarries too. Most Western quarries have ambitious CO2 reduction goals, especially where cement is concerned, making slashing CO2 output a top priority. So, what can we do? It may seem obvious, but we can start by simply burning less fuel. Experts believe that up to 95% of a diesel-powered earth-moving machine's total life carbon emissions come from fuel use. So more than other consideration, our primary responsibility is to minimize fuel use wherever and however we can. The good news is, there are ways to reduce emissions at every stage of the quarrying process, and many of these changes will have the happy side effects of decreasing costs and increasing production. By looking at fuel usage per stage, we know that up to half of all emissions come from hauling, with the rest split across overburden removal, extraction, and the yard. Let's look at these in turn. We can start by ensuring overburden is removed layer by layer, working downwards from the topsoil with excavators only. This helps minimize resistance, cutting down both time and intensity of fuel burn. Next, we can ensure our machines are used as fuel efficiently as possible. Simply by having the loading machine elevated on an overburden bench and swinging out no further than 45 degrees, fuel efficiency can be increased by almost half. Over the course of a year, with 500,000 tons of material being moved, the reduction in fuel usage and machine hours is staggering. In most cases, extraction starts with a bang. Blasting is by far the most efficient way to free stone from the ground, but it requires balance. Use too much explosives and we risk destroying the very rock we're after, but use too little and we leave huge unbroken rocks that are hard to load, harder to haul, and impossible to crush without being broken down further, all of which burns through more and more fuel. Once rock is ready for loading, we have another important decision. Which machine do we use? It's wheel loader versus excavator, and they're very different animals. Where both weather and environment are kind, nothing moves material like a wheel loader. But on uneven ground, or in a tight space, the wheel loader cannot compete with the excavator. Agility, stability, and the longest of long necks allows the excavator to thrive in rough, unstable environments. And with tank-like treads and a 360-degree field of motion, an excavator stands where it likes and moves where it chooses. By picking the right machine for the right site, we make our extraction operation as efficient as possible, burning less fuel and emitting less CO2 wherever possible. Applying the lessons of overburden removal, we know to keep excavator swing radius short and to always load from above. Excavators should load from the bottom of the rock pile, where gravity has gathered rock together flat on the floor and made it easier to penetrate. Digging here, instead of the jigsaw of rocks found in the middle of the pile, reduces loading times, improves fill factors, and decreases fuel burn. When relying on a wheel loader, the knack is knowing exactly where to stop. The perfect distance from face to hauler, taking the least time and burning the least fuel, is 1.5 tire revolutions. Wheel loaders give operators the perfect tool for keeping a loading area clean, but after hours of work, this can become challenging. Having the right ground engaging tools, or GET, can make arguably the single greatest difference to efficiency and fuel use. GET come in all shapes and sizes. Like teeth, sharp ends help cut into tough surfaces, while flat surfaces help crush and break down material. Wearing matters too. If you've ever tried to push a blunt knife through cold butter, you've experienced the feeling an operator gets when using overly worn GET. Far more effort is needed to break up stone, wasting fuel and potentially overworking the engine, transmission, and hydraulics. Some modern GET types are actually self-sharpening and far easier to fit and change than older models, making it easier than ever to build fuel-saving efficiency into the front of every loader. Finally, payload management systems can help operators avoid the twin dangers of underloading and overloading, resulting in more trips to the crusher or increased fuel burn per trip, respectively. Of all the stages of quarrying, the hauling process typically uses the most fuel. This is in part unavoidable. Large trucks carrying heavy stone need a lot of fuel, but, as always, there are ways to use a lot less. Efficient hauling is all about minimizing rolling resistance, the extent to which the ground resists the tires of the machine moving over it. Anyone who has ever ridden a bicycle with underinflated tires knows exactly how rolling resistance feels, and how incredibly hard it can make moving even light loads. The key to keeping rolling resistance to a minimum is to have well-designed and carefully maintained haul roads. Roads should be built high enough for water to run off, flat enough so that no gradient exceeds 12%, and wide enough for even the largest machines to pass one another safely. Once built, every part of the haul road must be kept clean, clear, and as flat as possible. Motor graders can smooth the surface, wheel loaders can clear away debris and fill in potholes, and water trucks can deal with dust. Not only do smooth, dry, level surfaces help haulers burn considerably less fuel, they also minimize the stresses and strains on their tires, significantly expanding their working lifetime. Even on ideal haul roads, hauler operators have a real role to play in saving fuel. Using the correct power mode, driving at the right speed, matching gears to gradients and using the right braking systems in the right places. All of these help keep fuel usage as low as possible. By the very nature of quarrying, some idling is unavoidable. When taking on stone or dropping it off, the hauler must keep its engine turning, and it's recommended to idle engines for several minutes after switch on and before shutdown. But too much idling burns through fuel needlessly. If timings are off or machines are badly matched, trucks can sit idle at the rock face, at the crusher, or, if the haul road is too narrow, even on the road between the two. It's such a small thing, but switching idling engines off, or automatic engine shutdown systems on, is by far the simplest way to avoid wasting fuel. In the yard, fuel economy begins and ends with organization. Generally, whatever sells most should be nearest to hand, and less popular products stored further away. Yards can also be arranged around particular projects. One area might be reserved for materials making a new highway, while another is set aside for the building of a new hospital, and so on. Such a setup requires a lot of room, but effectively gives customers their own micro-yard. As a rule, though, material in stock should only be moved once, from pile to truck. While every yard is set up differently, there are some basic rules that must always be obeyed. The first is to place piles as close to the plant as possible, and to keep surfaces as clean and flat as possible. Every extra metre a wheel loader must travel, and every needless degree of incline or decline it must traverse, increases journey times and burns fuel needlessly. Over the course of a year, the same operator driving the same machine would spend 260 more hours at the wheel and burn almost 35% more fuel for the same production. Nothing wastes fuel like idling machines and needless work. When too few loaders are on duty, it's customer trucks that are forced to idle, burning through their fuel and their patience. But when too many loaders are on duty, it's our fuel that's wasted, as idling grows and the likelihood of in-yard traffic jams increases. Loading a customer's truck is a tricky business. Load too little and we waste time and fuel for both parties. But load too much, beyond their road legal weight, and we could get customers into real trouble and cost them real money. And all too often, the only way to deal with a badly loaded truck is to tip everything out and start again, doubling workload and fuel usage. A surprising amount of sustainability advances happen not in the quarry, but here, in the workshop. Maintenance is a balancing act. Change filters and oils too often, and we increase both waste and emissions. Change them too seldom, and we risk damaging the machine. But now, with recent advances in filter design and oil formulation, it's possible to safely double the time between services, halving our waste at a stroke. Where parts are broken, they can be replaced with components from machines no longer used for production, or with remanufactured parts, which have been repaired and repurposed. This can really reduce a component's CO2 footprint, along with many other measures of sustainability. Tyre maintenance is essential to keep haulers' rolling resistance to a minimum. Even the slightest drop in pressure can significantly reduce a hauler's performance and drastically decrease fuel efficiency. As tyre pressure drops, heat and rolling resistance rise, and we must burn more and more fuel just to keep moving. Using underinflated tyres also drastically reduces their lifespan, adding in a second needless carbon cost. Finally, there are the engines themselves. More and more modern engines are being built to run on electricity alone, or to harness the power of renewable or low-carbon fuels. These advances from the workshop, once applied to an operation, can help significantly reduce CO2 output. But how can we measure this? Most quarries, and almost all modern machines, now use payload management systems. These allow operators to see payload weights in real time, and make perfect loading weights the rule rather than the exception. By monitoring the performance, fuel burn, and CO2 output of the entire fleet and production monitoring systems can provide an ever-updating, quantifiable picture of a quarry's emissions, providing opportunities to increase productivity, fuel efficiency, and sustainability. One example is truckload time. By monitoring time taken to fill each truck in real time, A site manager can immediately detect when inefficiency has crept in and trace it back to the source, be it bad blasting, poor operator technique, or overly worn GET. In fact, by using such monitoring systems across their entire operation, and by implementing all the innovations and tricks of the trade we've seen, many quarrying operations have already managed to reduce their CO2 output significantly over the last decade. That's progress to be truly proud of. So here we are. We've learned how to cut CO2 emissions across every stage of the quarrying operation by choosing the right machines, the right equipment, and the right techniques. Even more importantly, we've learned that sustainability and profitability go hand in hand. And as stone makes its way out into the world to become a home or hospital or highway, we realize that the secret of sustainability is to always ask if we can do more. Because when we do, everyone wins.